Welcome back, everybody. Today we'll be looking at physics paper 5, especially the October-November 2013 variant 51. And let's get started. This is going to be a series of videos where I look through paper 5 and break it down. It really this was one of my favorite topics for physics, so it's fun for me to share it with you guys. Right, so moving on. They give you a question as such. Sometimes they might give you an apparatus. Sometimes they might give you a setup as figure 1.1. They'll give you a general question. They will tell you what is changing. They'll tell you the relationship that you have to test. They might give you an equation, but they usually give you an equation. Most of the time, that's an equation. And then they'll give you'll have to work with this equation to prove this relationship. And sometimes the equation helps you find out independent, dependent variables, etc. Um, and they'll give you some additional information in the question. So let's see how to think it through. First of all, get a general idea of what's happening in the experiment. Think about the theory that you're taught in school and how it applies to the experiment. Next up, you have to figure out the variables: independent variable, dependent variable, and constant variables. This is useful because these independent you have to once you know the independent variable, you have to worry about how to change the variable, and then the dependent variable will be how to measure the variable. And once you have the constant variable, it helps you understand how do you maintain a variable so you have a reliable test and every value can be compared reliably. And also you have to use the equation to find the variables. Like in this case, you have to find the relationship between H and F. So either H or F is the independent variable, for example, and then N and K will be other constants that we can worry about later. We'll have to linearize it because in physics, it's easier, at least physics for A levels in A2, AS and A2, we only have to deal with linear graphs in our physics paper, practical papers. You may have drawn a curve for paper 3, but then they don't expect you to know much about the function of a curve. They don't expect you to do much with it except find gradient at certain points. In this case, we will always linearize the equation to prove a relationship. So a few questions to ask yourself while you look at the question, while you look at the setup, while you read all the data is how do you change a variable? This is in accordance with apparatus. How do you measure the variables? Usually, again, apparatus measure. So for example, if you have to change the length, so you might need to use a meter rule to measure the length. We have to use vernier calipers to measure the length. You might use top band balance to measure out a certain amount of water, for example, measure out a certain um, mass of a coil, for example. If you need to find the mass of this coil, you have to use a top band balance. If you have to change the mass of the coil, you might attach more mass to it, like external mass, for example. How to maintain a variable. This is usually for constant variables and ensuring there's a reliable test. For example, if you're dropping something from a certain height, it would be more reliable to drop each mass from the same height, so you can compare the impact of the mass, etc. Like it depends on the question. And the last thing I would ask myself, and this helped me a lot, was how do you make yourself comfortable? This is helpful if you have done the experiment in the lab. Um, However, how would you make yourself comfortable, or how would you do something differently? Helps you answer the additional points part of paper 5. Um, I will get into this as we move on, but let's just start with the analysis of the question. As you can tell, this is basically electromagnetism. They're testing electromagnetism as theory. So as the frequency of the current changes, the rate of change of magnetic flux linkage in the coil will change, and then the magnetic flux linked to the aluminum ring will change, which induces an opposite pole. Thus, as the magnetic flux linkage increases, a greater current is induced in the coil, and the force of repulsion between the aluminum ring and um, the coil is greater. So again, that's basically the theory behind it. You don't need to understand the theory behind each practical paper. That's the good thing about physics paper 5, but it really helps if you understand what you're doing. Try your best to understand it. If you can't, just stick to the basics of proving the equation, varying the independent and dependent variable. However, for me, if I understand the theory, it helps me understand what variables are easy to change, what variables make sense to keep constant, for example. I shall explain this later on, but let's move on. Using the equations, they give you H equals to Kf raised to the power of n. So now we must manipulate this. So either H or F in this case. It is easier to vary the frequency supplied to the coil. Like I said, if you know the theory, it's easy to know what you have to change. It's easier to change the frequency of the alternating current applied to the coil using certain apparatus, for example, as compared to keeping the height constant. Because you see this ring is wobbling, it's going to be difficult for you to keep the height constant. It's easier to change the frequency and then measure the height that is obtained at that frequency as compared to setting a frequency of, let's say, 25 centimeters, 10 centimeters. It's going to be extremely difficult in the, for example, if you think about it in a sense, you're carrying it out yourself because that helps you plan or formulate or create a procedure for someone else to follow in this case because you're planning, right? Um, so hence F is independent, or the frequency of the alternating current supplied to the coil is independent because it's the easiest to change, and H is dependent because like I said, it's easier to measure H. So it is easier to vary the frequency supplied to the coil rather than it is to measure the frequency required at that certain height, like I said. And also to keep the experiment fair, the number of turns of the coils should be kept constant because magnetic flux linkage is proportional to the number of coils. So if we increase the number of coils in between experiments, it will not be reliable because the magnetic flux linkage is not going to be constant at the same frequency. So if you use the same frequency, but you have the larger number of coils, the magnetic flux would be greater, the repulsion would be greater, and then the data will not be comparable. You have to make sure your data is comparable. Okay, so keep the experiment fair. The number of turns of the coil should be kept constant, and the current should be kept constant, as changing the current or the number of turns will affect magnetic flux, right? Furthermore, also increasing the peak value of current will affect the repulsion. So greater the peak value of current in the coil, greater the repulsion, hence it's not going to be comparable. Furthermore, it would make the experiment fair as we want to only find a correlation between two factors. That's because that one way to think of it is we're using a linear equation, and in a linear equation, the independent value will change and we measure dependent value. If you change more than one value, then the dependent value it's going to be difficult to compare them with each other. So forming a linear equation, as the given equation contains constant variables in exponents, we have to use logarithm. It can be log base 10, it can be natural logs, log to the base e, or ln, for example, to linearize the equation. So we take logarithms on all sides and we simplify to log h equals to n log f plus log k. If your logarithms aren't strong, please look for resources to strengthen your logarithmic techniques and concepts. So I know some students don't take maths along with physics, so I might make a video on logarithm just for physics students, so that it will be easy for you to understand the logarithmic rules that you need. It's not a lot; it's just a few, and you'll be fine. So log h equals to n log f plus log k. Now this must look familiar. So it's familiar because it resembles y equals to mx plus c. Now, n and k are constants. So log k is a constant, which plays the role of c. N is a constant, so n is the gradient. And log f and log h are y and x respectively. So I shall get into this when I give you my breakdown or my in the next slide. So in a few slides. So next up, you have to draw a diagram. A diagram is required. Yes, they give you a figure 1.1, they give you a setup, but you can't say copy the setup as shown in figure 1.1. You have to draw your entire setup yourself. What you're going to use, you should draw it out. And I would recommend before you start writing anything, draw the diagram because it helps you conceptualize what you're doing, and you can erase your diagram, you can fumble around with it, and then you will realize that you'll figure out that more variables you must keep constant. So if you're given a diagram, copy it down and then draw additional apparatus. Draw measurement devices, any of them that you use, meter rule, for example, ammeter, voltmeter for electrical circuits, for example, and physics applies. Duh, it's a physics exam, right? All apparatus must be clamped or placed on a support. For example, this meter rule isn't floating. It cannot float. You can't just draw it here. You must draw it to a clamp onto a retort stand. Okay, and label everything. My drawing is not perfect. I did not label the metal retort stand that the coil is in, and I didn't even label the coil itself. But I have but I have made improvements, and it's in the later slides. So include any additional information in the diagram if needed. Um, we shall see later what it could be. It can be a camera, for example, and whatnot. Drawing can help you realize certain important things to consider. For example, I've realized that I needed a reliable way to measure the height. As the aluminum ring wobbles about, I would have to either wait for the aluminum ring to stabilize, or I could use a slow motion camera to measure the highest point reached by filming the motion and rewatching it frame by frame. So in this case, I didn't draw the camera in my diagram, but you could draw it. I would recommend you to draw it out if you can, if you have the space, draw it out. Also, draw big diagrams. Don't draw small diagrams. My diagram here is actually very small, and if you make a mistake, it you'll cause the entire diagram to smudge about when you draw it in pencil when you erase it. So draw big diagrams, take up all the space you need, and draw it clearly. Label everything. Your drawings don't have to be the best. You don't have to be an artist. Just draw something that looks like the apparatus. Like, look at this ring and this coil. It looks nothing like this, but I've just drawn it and I've labeled it. It makes sense. The examiner will understand. All right, so this is my response. I wrote it exactly as such. And it's you can write in point form. There's no need for you to write full sentences, and I would recommend you to write it in point form as well because it saves time. So first thing that I do is I write out independent, dependent, and constant variables. There's 3 marks or 4, sometimes 2 marks for this. So independent variable, I just write frequency of alternating current F. Dependent variable is height of the coil or maximum height of the coil reached H. Constant variables, number of turns of the coil, and peak current in coil. I would recommend you to write full sentences for this because sometimes it's a bit vague. So keep the number of turns of coils constant, keep the peak current value in the coil constant, instead of writing constant variables and writing that. So the procedure is use a signal generator to generate an alternating current supply that is connected to the coil. Use an oscilloscope attached in parallel across a resistor and measure the voltage across the resistor. Constant peak voltage equals a constant peak current, or use an ammeter, but it's more difficult in practice. Right, so if you don't know what a signal generator is or what an oscilloscope is, I have it here. So an oscilloscope or storage oscilloscope is basically measures a change of a value with time. It's usually time, but the y gain and the x-axis can be anything. So when measuring voltage, or in this case, or using basically or current, because you're putting it in parallel, you can't measure current. Um, Oscilloscopes have infinite resistance, so you can't put it in series. Um, so you have to put it across a fixed resistor and then put the oscilloscope in parallel across the fixed resistor. And then use R equals to V over I formula, and then to check the peak voltage. If the peak voltage is constant, the peak current is constant, and it can also be it's useful in measuring frequency of an alternating current, because the x-axis or the x-axis is basically time, the smallest division of time multiplied by the length of one complete wave. So an alternating current is usually have a sinusoidal or a cosine wave, for example, and then you to find the period of one wave is basically the length of one wave times the length of one complete wave times the smallest division of time. So you can state it exactly as this in your answer, and but it's usually used to measure a value that changes with time. It can be anything. Next up, we have a signal generator. A signal generator is one of a class of electronic devices that generates electronic signals with set properties of amplitude, frequency, and wave shape. There are many uses. For example, it can be used to generate an alternating potential or an alternating current and a frequency It can also act as a frequency generator for sound. So you can produce different frequencies of sound. It is a box with dials and can be adjusted to give a desired effect. You could just set the peak voltage and the frequency at which the potential varies. Um, so that's basically the two apparatus, and that's the breakdown of it. Um, Try to Google some apparatus, look at some YouTube videos to get an understanding of how they work. There are multiple A-level channels that do physical breakdown, physical videos in the laboratory where they break down certain apparatus. You could just search them up and look at it. So next up we have just put in next up we have step three. Label your steps in as 1, 2, 3, 4, so that you can refer to the steps later on. So measure the initial height from the top of the ring. Because we're measuring the height moved, you need to measure it from the top to the top of the aluminum ring when it's reached the highest point. So you can find the maximum height or the maximum height traveled basically. So switch on the signal generator and wait for the ring to rise and stabilize. Measure height reached from the top of the ring H2. Switch off the current. Repeat steps 1, 2, 3, 4 at constant frequency values to find at constant frequency values to find multiple values of height and find the average value of height. Um, it's crucial to mention this because you don't take just one reading, you have to take multiple readings and find an average. So it's best practice to just write it out. And usually in additional points for paper 5, if you just already ingrain it in yourself to write it out, you don't have to worry about ensuring to write it again later on. Just include it in your writing, make it a form of practice to write it properly, to follow basic physics of finding average values, repeating when necessary, moving on necessary steps, repeat steps 1, 2, 3, 4, and 5 at different values of frequency to find distinct values of H at different values of F. So this line may not be necessary, but I write it because we keep the independent variable constant and find the average for the dependent variable. So if you write a procedure, you must mention to change the independent variable. So hence I say that I have to change the frequency and then find the next set of values of H. Data analysis. So you always write out the linearized equation. You might do rough work in pencil anywhere, but write it in pen, include it in your answer. Um, the linearized equation, usually you get a mark for it. And then you must mention plot a graph of log f against log h. Sorry, this is wrong. You have to plot a graph of you draw y axis against x axis. So you must plot a graph of log h against log f for the relation, and you must also mention how would the graph that you've drawn prove that your relationship is valid. So for the relationship to be valid, a straight line graph should be obtained that does not pass through the origin. Remember that you have a y-intercept, so it does not pass through the origin. Next up, you must, like the question says, you must find the question also includes you have to find the values of k and n. So I didn't include it in the snippet, but that's what the question asks for. So you must explain how you find the value of n. So the gradient of the graph is n, and the y-intercept is log k. So you have to find k, so you have to rearrange this so it becomes k equals to 10 raised to the power of the y-intercept value. Next up, this is a better drawing that you should have drawn in your examinations that I should have drawn. So basically, you have a retort stand, label it. You have the clamp, so you have labeled the clamp. You have the meter rule drawn properly. You have to use set squares. These are fiducial markers. If there's anything that is strictly vertical or strictly horizontal by 90 degrees, 90 degrees, you must use set squares to prove that it's 90 degrees, to test that it's 90 degrees. And again, I've included a signal generator. Remember, your drawing doesn't matter. Just draw it clearly. The oscilloscope is in parallel to the coil. So additional points, safety, and improved diagram. So there's usually a mark for safety. So if you have, and you have to think it's useful to imagine that you're doing the experiment in person because you can think about the safety concerns. So in this case, we know that when you switch on, there's heating when current passes through a wire, right? So if you keep the wire switched on for a long time, there could be heating in the wires that could, harm you. So you must mention switch off the current in coil when not in use to prevent heating. Or could you say wear insulating gloves to prevent electrocution when working with electrical supply appliances. So additional points is that I would consider while that you should consider is when measuring length, use a set square as a fiducial marker. So what does a fiducial marker mean? It's a way to it's basically a straight edge that signifies where that point is. So you put a set square at the tip of the aluminum ring so you can make an accurate measurement on the meter rule. You don't gauge with your eyes. You use a fiducial marker, which is a straight edge, like I said, and it will touch the meter rule at a point, and then you take the reading at that point. If you don't understand it, you could just Google a fiducial marker. Um, Clamp meter rule parallel to the setup. This is a mark that's given in the mark scheme, and this you could either mention it or you could just draw it out. So that's why I said to draw out all additional apparatuses that you might need because there might be additional marks for drawing it out. Um, Set up oscilloscope with time-based setting. Time period equals the length of one wave times time-based units. So also mention it in additional points. And then measure frequency F equals to 1 over T. So if you're using any equations like F equals to 1 over time period, write it out so you can get marks for them. And next thing is to keep current constant. I know we mentioned it here. Constant variables, number of turns in coil, peak value of current, keep it constant, but you must mention how you keep it constant. So example would be using a resistor and observing it with a ammeter or observing with the oscilloscope. So if there's a constant peak value for voltage, the current is constant, for example. Or if you see the reading on the ammeter is constant, then you know the current is constant, for example. But I wouldn't use an ammeter in this case because it's an alternating current. It would be difficult to keep note of the dial as it moves. It might move too fast. It doesn't make sense. So it's useful to use an oscilloscope so you can observe the graph and the peak value of the graphs. According to the mark scheme, using a signal generator to vary frequency, as long as you mention it in your answer, you get additional points. Using oscilloscope in parallel to measure time period, you get another additional point. And remember, mentioning relationship is valid if straight line is produced, as we included it here, is also an additional point. And also a fixed additional point that's given in paper 5 is actually mentioning to find the average of the height. So basically, as long as you mention to keep the um, independent variable constant and then varying it to find different values of height in this case, and then finding the average height, you get another additional point. And then we already discussed the apparatus breakdown. I hope you guys understood this video. I'll be doing more of them. I tried my best to explain the new apparatuses that we have used, for example, signal generators, oscilloscope. I hope you can understand the diagrams that I've drawn and the additional points. A lot of physics paper 5's intuition and thinking it through, imagining that you're actually carrying out the experiment. Um, because of the pandemic, some of you may not be able to imagine that, but you could search on YouTube, you could search on um, uh, on Google and look at experiments that take place. They don't need to be entirely linked to the A-level syllabus, but just getting an understanding of what happens in the lab is very useful. You'll get an understanding of how to think it through. But also just doing general practice of paper 5 questions might help you out as well. Thank you so much for watching this. If you enjoyed the content, please leave a like, please share this video. Check out all the other videos that we are putting up. I plan on continuing this paper 5 series and maybe starting with the physics A-level paper 4 series where I teach all the theory topics. Stay tuned for all of that. I apologize for the delay in uploading sometimes. I know we haven't uploaded in a long time, but please stay tuned and I hope you enjoy our content.